exact equation. An equation of the form m dx plus n dy is equal to 0 is known as exact equation. Where m and n are functions of x and y. Now, let's look at solution of exact equation. If a function z of xy exists whose total differential is the z is equal m dx plus n dy, then z xy will be equal c, where c is a constant. So an equation of the form m dx plus n dy is equal to 0 is known as exact equation, where m and n are functions of x and y. So what we are trying to say is that here that we have m is a function of x and y. Same thing happened to n. Now, the solution of exact equation, if a function z of xy exists whose total differentials is the z is equal m dx plus n dy, then z xy is equal c, where c is a constant, will be the solution. Now we want to look at the condition for exact equation. So condition for exact equation. Recall that exact equation that we have said is of the form m dx plus n dy is equal to 0. Now, for this equation properly to be exact, this condition must be fulfilled. Now, the equation is exact if partial m partial y is equal partial m partial x. So this is the condition for exact. Partial m partial y must be equal to partial n partial x. Now, we will now take example and see how we can solve exact equation. So, let's look at this example. Show that the equation 6x plus 5y minus 4 dx plus 5x plus 3y minus 1 dy is equals 0 is exact. Hence solve the equation. Alright, so let's pick solution. We have that 6x plus 5y minus 4 dx plus 5x plus 3y minus 1 dy is equals 0. Now here m is equal 6x plus 5y minus 4. Then n is equal 5x plus 3y minus 1. Alright. Partial n, partial x. No, partial n, partial y. Sorry. Partial n, partial y. We are differentiating m with respect to y. Will give us 5. Partial n, partial x. N with respect to x will also give us 5. So we see that partial n, partial y is equal partial n, partial x. So the equation is exact. And so we can now conclude that since partial n, partial y is equal partial n, partial x, the equation is exact. The equation is exact. So we have been able to show that is the first part of the question. Now the next, they said that we should solve. So there exists z xy such that partial z partial x is equal m, which is equal 6x plus 5y minus 4. Now, differentiate if I integrate this side. Of course, if I integrate both sides with respect to x, I will have z, if you integrate this with respect to x, you have z. Z is equal 3, okay, look at it, 6x integral 6x. Let me put it so that you really see it clear what we are going to do. I'm integrating with respect to x. So if I integrate here, you see, I will have 3x squared, because this is 2 over 2, then divide by 2, you have this, plus 5xy, then minus 4x. So it means that z is equal to this, plus c of y, that is constant. Constant in this context, we put c of y. And the next thing I will do is to differentiate this function. And if I differentiate with respect to x, no, with respect to y, then I will have partial z, partial y will be equal, of course it will be only this, we'll have 5x, that is, if I differentiate here with respect to y, 5x plus c prime of y. Now, but partial z, partial y is equal to n in total differentials. We know that partial z, partial y is equal to n. And here we have that n is 5x plus 3y minus 1. So I can now put it here that 5x plus 3y minus 1 is equal, I'm replacing this with n, is equal 5x plus c prime of y. Now that means I want to find c prime of y. And of course, c prime of y will be equal 3y minus 1. When you transfer this to this side, it becomes 0. So we have only this. And the next thing is to integrate this with respect to y. I have to integrate this with respect to y. So I have c of y, because this is c prime of y. If I integrate this, I have c of y. Then will be equal, integrating this, I will have 3y squared all over 2 minus y plus k, another constant. Now, this is the value of c of y. Yes. So I have to go back to my z so that I can substitute the value of c of y. And if I do that, I will have that z is equal 3x squared plus 5xy minus 4x plus 3y squared all over 2 minus y plus k, which means I can have something like this. Z minus k is equal 3x squared plus 5xy minus 4x plus 3y squared all over 2 minus y. Therefore, a will be equal 3x squared plus 5xy minus 4x plus 3y squared all over 2 minus y. A is equal z minus k. Okay, so I'm using a to represent this. So this is the function. Now we are going to look at another method that we can also solve exact equation. Let's look at the method. The simplest way we can also tackle that same problem. Now we know that this is n, the x, and this is n, the y. So m is 6x plus 5y minus 4, and then n is equal 5x plus 3y minus 1. Partial m partial y is 5. Partial m partial x is 5. So the equation is exact. Now z will be equal integral m dx plus integral sum of terms in n not containing x dy. And look at the pattern I'm using. If we use this, we can also reach the same point. Z will be equal m dx plus sum of terms in n not containing x. Alright, then dy. So that means z will be equal integral n is 6x plus 5y minus 4 dx plus integral sum of terms in n not containing x. Now in n, this term contains x, so we will not pick that one. This other two terms, so we'll have 3y minus 1 dy. These two terms are terms in n that do not contain x. So this, integrating this will give us the value of z. Now look at z will be, if we integrate this, with respect to x, we have 3x squared plus 5xy minus 4x plus, this is with respect to y, so we have 3y squared minus y. Look at that. So if you compare these results with what we just finished, you see that we have arrived at the same result. So you can either use this or the other pattern that we just finished. They are the same. Now we are going to look at non-exact equation. Non-exact equation can be converted to exact equation by using integrating factor given by the z all over mu is equal partial n partial y minus partial m n partial x all over n of xy, and this will be when this integrating factor is a function of x. That is the first case, and this will be p of x. Another one is we can use also integrating factor to multiply the given equation in order to convert it into exact by, now you know this is case 1 that we have said. Case 1. So case 2, the z will be equal partial n partial x minus partial n partial y. Then we have m of xy, which will be q of y. Now you see that in the first case, case 1, if we have the z all over mu is equal p of x, now integrating both sides, we'll have that ln mu will be equal integral p of x. Okay, so this will be the integrating factor that we can use to multiply. But you see that taking ln of both sides, this will imply that mu will be equal exponential integral p of x, the x. So we use this to multiply through the given equation. Same thing will happen to this. In case 2, if the z all over mu is equal q of y, then integrating both sides, we have the mu is equal integral g of y. So that taking logarithm of both sides, mu will be exponential raised to integral y. Okay, the y. So if we use that to multiply the given equation, we can convert it to exact equation. Now let's look at the example. The example is show that the equation 3xy plus y squared plus x squared plus xy divided by x is equal 0 is not exact. Hence, find the integrating factor that will convert the equation into exact equation. Okay, let's take the solution. We have 3xy plus y squared plus x squared plus xy divided by x is equal to 0. You know this equation could be written as 3xy plus y squared dx plus x squared plus xy dy is equal to 0. You know, the reason is here, this is divided by dx. So you will take LCM, which is dx. Then here is over 1. Then the x will times 1. You have the x times here. You have the x. Then the x will cancel the x. You have the y. All over the x. You times cross multiply, it times 0. So we have it in the straight form. Now, we see that m is equal 3xy plus y squared. And then n is x squared plus xy. Now, partial n, partial y, of course, partial n, partial y will be 3x plus 2y. Partial n, partial x will be 2x plus 1. Look at that. If you differentiate this, you have 2x. Differentiate this, you have 1. Partially. Alright. And we see that partial n, partial y is not equal partial n, partial x. So we have been able to show that this equation is not exact because partial n, partial y is not equal to partial n, partial x. But we can convert it to exact by saying that we have that dz all over mu is, we have m y, that is partial and partial y, minus n x all over n x y. I want to test this to see whether it is function. If it is function of x only, then I will integrate with respect to x. Can also test to see if it is function of y only. But this will give me, partial and partial y is this. So we'll have 3x plus 2y minus 2x plus y all over n of xy. That is this function, n as a function of x and y. Okay, so this will give me 3, this will give me x, 3x, this will minus this. Then plus what? Plus y. How? Because 2y, this will open this and this will become minus, so half y. All over x squared plus xy. Of course, I can write this. I can write this as x plus y all over x plus y. Look at that. Because if I times it, I'll get back this and this. So what it means is 1 all over this. Okay, this can cancel this. So I have 1 all over x. So I'm going to integrate the z all over mu is equal 1 all over x. And if I integrate this, of course I will have that mu will be equal integral of 1 all over x, which is the same, integral of 1 over x. We have exponential integral 1 over x dx, because that is what we said. We will integrate it with respect to x because this function is function of x. Of course, it's function of x only, which is the same as exponential ln x. If you integrate this, you have ln x. Now, exponential ln of a function is equal function. So mu is x. Now that we have the integrating factor as x, we'll now use the integrating factor to multiply the given equation, which will convert it to exact. Now, let's see. The given equation was 3xy plus y squared dx plus x squared plus xy dy is equal 0. Now, multiplying through by x, we'll have 3x squared y plus xy squared dx plus x cubed plus x squared y dy is equal to 0. We have multiplied the equation by x, which is the integrating factor. So now, m is this, yn is this. Partial m, partial y will be, if we do this, you have 3x squared plus, here will give us 2xy. Okay, so partial n, partial x will be 3x squared. Then here, with respect to x, we have plus 2xy. Alright, so we are able to see that this one is equal to this now. Therefore, z will be equal integral m dx plus integral sum of terms in n not containing x dy. So if we have that, we then have that z will be integral m. What is m? M. We have our m is here. Now this is the new equation. So we have integral 3x squared y plus xy squared dx plus integral sum of terms in n not containing x. Okay, so there is no term in n that does not contain x. The two equations contain x, which means there is zero term there, the y. And here, if we integrate here with respect to x, we will have x cubed, x cubed y, because this place we will put 1 here, 3, the downside 3 will cancel here, plus going here we have x squared y squared all over 2 plus c. So this becomes the terms, the function for z. So this is how we can convert not exact to exact using integrating factor. Now let's take this exercise. Solve the equation y is equal to 4 plus 3y dx plus xy cubed plus 2y is equal to 4 minus 4x dy. Now, this equation now is in the form of exact, but we have to test for the two cases when the integrating factor is function of x and function of y, and see the one that suits it. Then for this one, we have to find the integrating factor that will convert this equation to exact equation. Hence, then solve. Now from what I have just shown you, you can follow that pattern and then you solve the equations correctly. Now let's move to another subtopic.